Okay, so of course it has been crazy over the last few days. Missing school on Tuesday for weather day. Yesterday was late start, so it's just been crazy. But so most of the stuff we're going to talk about today is stuff we've already been talking about. There's a couple of things I'm going to add in here, like this first part, which is simple, but I want to talk about this. So we've been talking about splitting circles up in degrees, but I want to talk about splitting them up as a percentage. So with the percentages, what should those numbers add up to?
360.
The percentage should add up to 100, right? Now, if we split it up in degrees, what should those add up to? Into 360. Okay, so here's what we're going to do. Number one, we're just going to look at where each of these should go, and then we're going to find out how many degrees that slice would be. So let's just think about this. This 5%, which slice is going to be the 5% slice? It's this little one right here. Where's the 65% slice going to be? It's going to be this one over here. Where's the 20% slice?
The second biggest one. Wait, what? Wait.
Don't do this.
Can you watch Frozen 2?
Okay. So then the 20% is going to go here, and the 10% is going to go here. So what I want to know is, okay, this little slice right here is 5% of the circle, but I want to know how many degrees this arc is or this angle is, which is going to be the same number. Okay, so the question is, what is 5% of 360?
Isn't it like 3.6 something?
Well, we're going to do 360, and then we're going to change the 5% into a decimal. So remember, if you move it once, twice, fill that in. So 360 times 0.05, and that's what? 18 degrees. So this arc is 18 degrees, or the central angle there is 18 degrees, however you want to think about it. Okay, the 65%, so 360 times 0.65 to find 65% of 360. What is that? 234. Okay, so that arc out there is 234 degrees. The 20%, 360 times 0.20 is what? Is 72. That's going to go right here. And then 360 times 0.10 is going to be 36 degrees. Okay, so pretty simple. But I want you to go ahead and do the same thing on the second one. Find out what goes where, and then find out the degrees for that slice. Okay? So go ahead and do that on this second circle here. Okay, so let's just go ahead and start from the smallest one and work to the biggest one. So this 17%, which slice is that going to go on? That top right one, right? So 17%, so how many degrees is that? 61.2 degrees. All right, the next one is a 21%, so where's that one go? Okay, yeah, so right underneath it, so how many degrees is that? 75.6, and the 29%, where's that going to go? At the bottom. They're very, very close, but the bottom one is just a tiny, tiny bit smaller. So how many degrees is that one? 104.4, and then the 33 obviously goes right here, and it is 118.8 degrees. All right. Next. What is the degree measurement of arc AB? Yeah, it's 40. It's the same thing as the central angle that makes it. So that is 40 degrees. Okay, how big is arc DC? Right here, same thing as that. So that's 50. Okay, how big is arc BC? Okay, are you saying 90 just because it looks like it's 90, or...
Because 5 and 40 are 90.
Okay, good. So from here to here is half of a circle, and that's 180. And if you have 180 minus 50 minus 40, then that leaves 90. So this right here is 90 degrees. Okay, how big is arc AED? AED is half of a circle. That is 180 degrees. All right. Arc BD. So BD is both of those are those pieces together, so 90 and 50 together makes 140. All right, I forgot to put this. Okay, arc AC. 130, because it's that 40 and 90 together, which adds up to 130. All right, next our arc BAD. Okay, good. So BAD is half of a circle plus another 40, so that's 180 plus 40, which is 220. Okay, arc ADC. So that's half of a circle plus another 50. So 180 plus 50 is 230. All right, arc ACB. Okay, so ACB. So you got to get to C before you get to B. So you got to go all the way around like this. So it's nearly the whole circle, but without that 40. So 360 minus the 40 gives us 320. All right, arc ABD is 180. Arc CED is what? Is 310. The whole thing without that 50 degrees included. And then BAC is 270 because it's everything excluding that 90 degrees. So that's 270 degrees. Okay, on this right here, number 26, point C is a point of tangency. So 26 is B. Now, I have no idea why there's two number 27s on here, but there is. So on the first number 27, AB is a secant. That's F. On the second number 27, CG is a tangent. That is G. Okay, I'm giving you those three because we haven't talked about those three yet. We'll talk about them next week. But I want you to go ahead and match the rest of those up there. Okay, so QC on this circle is a what?
Radius.
Is a radius, C. Okay, number 20, arc BDE is an example of what? A major arc. It's more than 180. Okay, AD. It is a diameter. It's a chord that goes through the middle, through the center. Okay, arc ABD. It's a semicircle. It's half of a circle. Okay, angle AQB right here. That is a central angle. We'll talk about inscribed angles next week. Okay, point Q is the center of the circle. Okay, ED is a chord. That's D. And then number 28, arc EA. That is a minor arc, so that's J. Okay, on the back. So just a couple of random little things here that we've talked about. So on this, okay, in half of a circle here, how many total degrees would these, they would be 180, right? So we would do 6x plus 12 plus 2x plus 88 together all equals 180. And I'm not going to work through that. Just combine like terms, solve for x, and you get x equals 10. Okay, next one. So this is like what we talked about yesterday. Okay, so this chord and this chord are congruent. They're both 6 centimeters. So if those two chords are congruent, what do I know about these two angles right here? They're congruent, right? Now, if those two angles are congruent, what's that going to tell me about these two arcs out here? They got to be congruent also, right? So basically, everything's all congruent here. So since those chords are congruent, the angles are congruent, the arcs are congruent, so we would just set those equal to solve for x. 5x plus 16 equals 7x. And again, I'm not going to work that out, but if you work it, you get 8. Okay, on this next one. Okay, so what I want to know is I want to know the length of this arc right here. We'll know the length. So how do we find the length? What's the formula? There you go. 2 pi r times m over 360. So what's the two things we need? We need the radius and we need the measurement of that angle. Okay, so I've got the stuff right up here. Okay. So how long is this radius? About 2.9. And now we need to measure the angle real quick. So it's just a tiny little bit more than 110. So we'll just say 111. That'll get us pretty close. All right, so we're going to do 2 times pi times 2.9 times 111 over 360. No. Okay. We got what we need there. So 2 times pi times 2.9 times 111 over 360 is what? 5 point what? 5.62 centimeters is the length of that arc right there. Okay. Now this last one. So we're looking for the length of CE. The first thing I need to know is how long is the radius of this circle?
25.
Okay, so it's 20 plus another 5. So total, yeah, that's going to be 25 inches. All right, so if I draw a line from here to here, how long would that line be? 25 inches. But that doesn't help me. What if I drew a line from here to here? How long would that line be? Okay, would that be a good line to draw? Yes, because we made a right triangle right there. And so how could I find the length of this side down here? Pythagorean theorem, exactly. Okay, so we're going to have 20 squared plus x squared equals 25 squared. And so you have 400 plus x squared equals 625. Take away 400, x squared equals 225. Square root of 225 is 15. Okay, but that is from here to here. It's just this distance. So how long is the whole CE? 30. It's going to be double that, which is 30.